Hello guys, in this video I am going to show you how the response spectrum analysis is done in etabs. So first of all I am going to show you the loads that I have applied on the structure. I am having a G plus 1 story structures. I will be going to show you the loads that I have applied on the structure. I have superimposed it load as you can see here 0.35 k per foot and the boundary wall parapet 1 k per foot per the 9-inch thick wall. So first, for performing the RSA, first you need to define your load pattern. Is in my case, I have defined the load patterns as live load, superimposed dead load, and the earthquake in the x direction and EQ in the y direction. For the earthquake and the x direction, I have input all the parameters that are required. Let's for the concrete from the ASC, we have concrete moment resisting frame for its value of 0.016 and x value 0.9. So for that we have 0.016 and zero point 0.9. For the short period spectral acceleration, I have given the default values which 2.29. In simply it you can the short period SS and S1 it is simply if we have a higher SS value, it means that these ground shaking, these strong ground shaking, these are the most dangerous for the strip structures and for the strip structures and the structures that having a shorter time period. And the 1 second spectral acceleration, these shakings, these accelerations are dangerous for the structures having higher time period and the structures that are flexible. And the long period transition we do up 8 and site class I have taken site class D as our code recommended when we don't have a geotech report, site investigation report. We can go with the site class SD and if A is for short period spectral acceleration and if V is for the 1 second spectral acceleration, as you can see it in your AC 716. And what's the procedure to calculate the SDS value? Short period design spectral acceleration and 1 second design spectral acceleration. I can go with this and the same here. I have EQY pattern, so I don't have to waste time on these things. After that, you have to define your mass source. We will be going to define what our mass source is going to be. Is we will be according to code. We will be going with the loads that will be during an earthquake on the structure. So we have taken one time dead load, one time superimposed, and the 25% live load is according to AC. We have to take 25% of the live loads in our mass source. Now it's okay. Now we have to define our response spectrum function. So response spectrum functions is I have defined. I can delete these one. Now I'll be defining my response spectrum function AAC 716. Define new function. I'll call it as response spectrum. Response spectrum. I have taken the same values of the default 2.29, 0.869, the same, and I'll take the site class. It's site class D. So all the things here that I have explained, FAFV. So that's my function. I can delete this one, so it can be deleted. Just go on with this one. So now I have to define my mass source. My load case. Sorry, load case. So my load case, I have already defined the load cases. I'll delete this one. I'll add a new load case. So my load case will be RS in the x direction, response spectrum in the x direction. I'll be going. My load case type will be response spectrum and the mass source will be mass source, and I'll add a load in the u1 mean the x direction, u2 in the y direction, and u3 in the z direction. My load function will be, as I have taken my load type of acceleration, my acceleration will be response spectrum, and the scale factor according to the code is we can see here my load case. For the scale factor, the value has to be divided by r by I. The value has to be divided by the quantity r by I. So it means we have to divide it by r by y. So it means we can multiply it by, as my importance factor is 1, and I'll divide it by my r value, that's going to be 8. So my scale factor is 48.261, and model combination type is I have to go is the preferable method, as the preferable type is the CQC. I will go with CQC. And directional combination type, I don't have to do anything with it because I haven't taken the load case and the load case UI or use it in the same load case RSX. So it doesn't mean if I have take is absolute or something else, is my only load is in the x direction. In this load case, I model damping will be at 5% and the diaphragm eccentricity will be 0.05. So that's okay. And now I can get a copy of this load case, and I'll call it as RSY, and the load case will be in the U2 direction, and the same is, and all of these are the same will be for the RSY. And okay, now what I have to do, I have to check my load case, model load case. I will be going with eigen analysis, eigen, and the number of modes will be 12. As 12 number of modes will be work, I expect that in 12 number of modes my model participation will be 12, and the minimum number of modes will be one. Frequency, no, we don't need here frequency, and the conversion tolerance will be it's the minimum, it's the number of iterations. Okay. So that's okay. And now I will be going to run the analysis. Okay, it can take a little bit of time. So okay, after my analysis done, it's 82%. After my analysis, I'll first be going to check the model mass participation ratio. Is I have to uh, the model participation mass ratio is per AAC 716. The model participation ratio in analysis shall be conducted to determine the natural modes of vibration for the structure. The analysis shall include a sufficient number of modes to obtain the combined model participation of 100% of the structure's mass. So I can show you here that what my model participation is. I structure output and model information, model participation mass ratio. Sorry, it's the load participation model participation mass ratio. You can see it here. For the 12 number of modes, our model participation mass ratio is 91% and 89%. Uh, we have to increase the number of modes. Okay, let me first unlock the model, and we are going to define load cases. Model load case modify, and I'll be going with 15 number of modes. So increasing the number of modes, the participation in the ux direction, in y direction increases. So the code also allows the model participation of at least 90% of the actual mass in each orthogonal horizontal direction. Uh, our model participation ratio was okay because it was approximately equal to 90%, mean 89% and 90% is not a little bit problem. But okay, let me check after the analysis done. Let me check what's the results we will get. Okay, the analysis results. Analysis, structure output, model information, model participation mass ratios. So model participation mass ratio is 92%. Now it's okay. Is the minimum is 90%, so it's okay. Now I have to check the base reactions. We can go at check table, and our load case will be EQX, EQY, RSX, and RSY. So the base here in the x direction is 731, and the RSX in is 330 is 375. Is the code says that the combined, yeah, the model base here is less than 100%. If it's less than 100%, then we have to multiply the ratio, the scale with the then we have to multiply that we obtain from the division of model base here and calculated base here. We have to multiply it with the scale factor. Let me show you something like where's my calculator. Okay, this one. So what we have to do, we have to 731.516 divide by 375.38. So our value is 1.9487. 1.9487. 1.94. Let me remind it, note it down. 1.9487. It's for the x direction. Now we will calculate it for the y direction. So 731.516 divided by 392.392.131. It's 1.865. Now I'll first unlock my model. I will unlock my model. Now I'll be going to my load case and the RS6 show modify load case. I'll be multiplying my this scale factor by 1.9487. 1.9487. Okay, and for the y direction I will be multiplying it with 1.865. 1.865. So now its RSY is okay. So now I'll again run the analysis. So after the analysis is complete, we will be checking whether the our base share is equals the base share from the response spectrum analysis. If it's matches with this, then our results will be okay. And now we're going result structure output, base reactions, show tables, and I'll be checking for EQX, EQI, RSX, and RSY. So our results are approximately equal. So mm, we will confirm we it's okay. The results are encourageable, or now it's that's your response spectrum analysis. Now you can design your building on the results of the base here and create frame design, and that's